Okay, I think we are good. Let me see. Okay, we have 5 more minutes to go. I'm going to start a video and I'm also going to go live on the official AWS channel. Once we hit the countdown of 0, is when I'll put everyone back in. Sounds good?
Okay.
Awesome. All the best, everyone. See you soon. No. Hi everyone. It's really good to be back into the Howdy partner world, and I'm glad to be back with a new partner today and excited to show you what we have in store. So, to introduce myself, I'm Gitika. I'm a partner solutions architect with AWS. And before we kick things off, Ulrich, why don't you introduce yourself and tell us a bit about Howdy Partner? What is it and who should watch?
Hi, everyone. My name is Ulrich Bosquet. I am one of the partner solutions architect with AWS, and this is Howdy Partner. And like you may have known, Howdy Partner is a weekly Twitch series highlighting AWS partner network, technologies, and partners that have built innovative solutions like we have today Imperva with us. And Howdy Partners connect to AWS community with APN network and APN partners to demonstrate all partners' solutions can drive bigger result and better business for the organization. And here today we have the Imperva team. Hi, Kunal. Hi, Raj.
Hey Ulrich, hi Gitika. Great to be here with you all.
Awesome. Raj, Kunal, why don't you go ahead and introduce yourself about your background, what exactly are we going to be working on today?
Sure thing. Raj, do you want to go first?
Sure, I could go first. Hey everyone, this is Raj. My full name is Rajaram. I'm the product manager for runtime security at Imperva. So I both lead both the RASP and our recent serverless security solution that we're going to talk about today. Prior to this, I was a developer for over 5 years, so I kind of have a little bit of background on how things were developed both on more traditional apps and also on more modern cloud native apps as well. Looking forward to the conversation today.
Awesome. And my name is Kunal. I'm Imperva's Chief Technology Officer. I've been at Imperva since 2018. I've spent pretty much my entire career in application security. I started off back at NASA and then later on at a social network that time forgot called MySpace. So definitely on the forefront of all sorts of interesting security escapades. I have a little bit of some of that that's going to be in a presentation later today that we're going to walk you all through. And then over the years, just spent a lot of time in that industry, started a company called Previty. We were focused on runtime security, ended up at Imperva in 2018, been the CTO here since 2019. And today we really want to spend some time talking about serverless security. Serverless is obviously something that's going to be here for many, many years to come. I think we were all floored when AWS made the big leap with Lambda, and we've seen a dramatic increase in the number of customers that we have, as well as people all over the world embracing serverless and serverless functions to basically to sort of compose and deploy business logic and applications. So we're really excited about walking through how we think about the world, what's going on in security, and we'll show you some fun demos along the way.
Awesome. I'm really excited to have both of you and to go through the demos as well. So for those of you who are not familiar with serverless technology, let me give you a quick introduction on it. Serverless is actually a way to describe the services, practices, and strategies that will enable you to build more agile applications so you can innovate and respond to changes faster. With serverless computing, you have infrastructure management, tasks like capacity provisioning and patching, all of which are actually handled by AWS. So you can only focus on writing code that serves your customers. AWS obviously has its own set of serverless technologies or services like AWS Lambda, API Gateway, S3, DynamoDB, to name a few that come with auto scaling, built-in high availability, and pay-for-value billing model. To go a little bit in depth with Lambda, it is an event-driven compute service that enables you to run code in response to events from over 200 natively integrated AWS and SaaS sources, all without managing any kind of servers. So what I'm going to go ahead and do next is I'll show you a little bit of a demo on Lambda function and how exactly it really works.
And Gitika, one thing worth saying to everybody, I mean, it's what I love about it is the 200 number, the fact that you've got a bunch of pre-wiring that's already done, right? And the fact that for the average organization, or if you are DevOps minded and you're trying to connect these services, maybe you're building an API and you want to connect your API to maybe a data store, or you want to connect it maybe to an S3 bucket. Maybe if something interesting happens, you want to trigger an event. And so I think it's fantastic that the number is now up to 200. I remember when this was first announced years ago, and I think there was maybe only a handful of initial integrations with Lambda. So it's come certainly a long way.
Exactly. And we have new things coming up in reInvent every single time, every new feature coming on Lambda, just to listen to our customers and release those integrations. So I'm gonna go ahead and share my screen, walk you through a quick Lambda demo. Um, Awesome. So I'm here in an AWS console. Let me search for Lambda. There we go. Takes a little while. So I already have like two functions already there, and what I'm going to do is I'm going to go ahead and create another function and just walk you through what exactly it looks like. So when you create a function, you get multiple options like authoring from scratch, using a blueprint. So there are already some codes which are available for you to be able to utilize, which have been created by AWS. So something like Dynamo Process Stream. That's a common use case which is already available. Then you have container image, browse serverless app repository, which you can again utilize. But today we are going to go with author from scratch. Let's see. So we are going to create Howdy partner. Let's go with Python today. So if you're not familiar how these things work, Lambda function requires permissions to be able to actually go and work with other services. I'm going to create a new role, existing role today. I have patch stream, already a role which I'm using, advanced settings. So advanced settings, you could actually modify and provide networking configuration to Lambda. I'm going to go ahead and skip this part today. I'm going to create a function. Was literally as easy as that. We already have a working function. Let's see. There you go. So this is going to be like a very basic hello world function that we're going to be looking at right now. So it's just hello from Lambda. Let's test it out. Let's see what happens. It will ask us to create a test event. This is fine. Let's create one and see what happens when we try to test it. So there you go. We have got our first hello from Lambda function in place. Now, I also have another script with me, which I'm going to show to you, which shows integration with DynamoDB as a service. So I'll show you quickly what exactly I have in my DynamoDB table. So we have partner name and when exactly we aired with them. So today we have Imperva, and on last Friday we had NXP. So this is what my current function looks like. It connects to DynamoDB. It gets details on Imperva. And what I'm going to do is I'm going to deploy this. So any changes you made, it was as simple to deploy as clicking on it. And what happens if I test this out? So right now it says task timed out after 3.02 seconds. So I'm going to make sure that this is not a problem for us. And this is another function aspect of Lambda that you can always change. You can create more memory, add more memory to it. Right now, I'm going to keep this as 128. What I'm going to do is I'm going to change this to 1 minute. I already know that it takes around 3 seconds overall, but I'm going to make it 1 minute and test and see what happens. So anything that you have to make changes to, memory, timeout value, it is literally as simple as what I'm doing right now. There you go. So now it was able to go and actually fetch those items right now. And we know that it took some 3.6 seconds total. And there we go. That's how a Lambda function looks like. And that's as simple as doing that. It can be integrated with other services like API Gateway, where you could have an API which triggers a Lambda function and then provides you with the result. This was a pretty hard-coded example to provide, but still gives you a good idea of how these integrations work in real time with Lambda. So next, why exactly is serverless important in today's day and age? Kunal already offered a lot of insights, but I'm just going to give some other benefits. So move from idea to market, it's really fast. We are eliminating operational overhead overall. Your teams can release quickly, get feedback, and iterate to market faster. It significantly lowers your cost with a pay for value billing model. Obviously, you never pay for over provisioning, and resource utilization is optimized on your behalf. So Lambda is only charged when there is a trigger for Lambda function. So unless it's running, you are not going to be charged for anything at all. Then it adapts at scale. It can go from zero to peak demands. You can build better application, which is easier. And then finally, serverless applications build service integration, so you can focus on only building an application instead of configuring it. And that was a quick demo and overview of serverless technologies. And the reason why we are actually going over it is because for those of you who are just joining, today we are actually talking about serverless protection with our friends from Imperva. That was it from my end. Kunal, Raj, why don't you guys take over and tell us about Imperva's product, how exactly serverless protection takes place with that?
Sure thing. Yeah, we'd love to do that. So again, I think it's worth echoing that we've seen a lot of organizations all over the world embrace serverless. And it isn't just people saying that they want to do some small experimentation with it just to see how it works and behave. We've actually seen a lot of organizations go all in. What surprised me was earlier this year, we got to talk to some really large financial services companies, and I won't name names, but one of them totally surprised us when they said that they were 100% in on Lambda, to the point where they had done a very big migration off of EC2. And they had moved everything over to Lambda, and really surprised us. And we started having more and more conversations with design partners as we were building up our serverless protection capability. And it just surprised us how many organizations were fully embracing AWS Lambda. And usually it starts small, right? You start by building some momentum. You maybe pick maybe a scheduled task, like the old school cron job, or you like take an existing application or a script that maybe it doesn't need a full stack like an EC2 instance. Maybe it just needs to operate. I mean, Gitika, in your example, you used Python, right? Maybe you want to just write 5 lines of Python or Node to query a database and maybe send an email using SES. All very, very simple to do via a serverless function, and you don't need the overhead of managing a really complex image or a complex stack. And so we started to see a lot of organizations go down this path. And again, what really surprised us was it wasn't just things like APIs that people were deploying and sort of decomposing into functions behind an API gateway. But what surprised us was a lot of organizations were just fully taking these applications that were tens of thousands of lines of code and breaking them up into these small logical bytes and really putting them together, stitching them together. It's just interesting to see. Usually when a new technology, a new paradigm of compute comes out, it takes time for organizations to really grok, understand it, and do something with it. And I think we're at that interesting point now where Lambda's been in the market for years, and now we're really seeing some large organizations and teams really pushing it. And I'm excited to see what happens with it. Now, I wanted to say all of those things, not just because we're on with you and the AWS team, but I wanted to say that because that informed our direction and us making a foray into serverless security and serverless protection. Because I think a lot of there's a lot of misnomers people have about serverless. Like, for instance, some people think that serverless, there's no such thing as servers. It's in the name, right? Not quite, right? Like, I think there's a lot of subtlety in, yes, the name is serverless, but end of the day, there is still a server that's executing, or that your code and your application, your function rather, is still executing on top of. And there's a lot that carries over from traditional application security into this world. And so what we wanted to do in our presentation today was, especially with the community here, was to do really two things. One, we wanted to show you what we built, and really building on top of knowledge as to what are some of the big security issues that people have to face today with serverless security and serverless functions rather. We want to dive in. We want to unpack the serverless top 10 when it comes to security issues. So some of you may be familiar with this group called OWASP, this open group that works on security. And they built out what they describe as the serverless top 10. We'll actually walk through it. I'm going to do my best to explain it at a high level. If folks want to go and have an in-depth discussion, or if there's certain things that they want to learn more about, just go in the chat in Twitch and just go ahead and ask your questions there. We'd love to answer some of those things in real time. And then the second bit is we wanted to show you what we built and get your collective feedback and your thoughts on it. Serverless is such a dynamic and changing space. We figured it would be great to show you what we built, why we built what we did, and get your thoughts and feedback. And if there's other interesting use cases that some of you are thinking about from a security perspective, as product builders, we'd love to learn and hear more about what some of those use cases may be. So that's ultimately what we are here to talk about and engage with the community on, and hopefully have a great discussion around as well.
Yeah, and just to reiterate, drop your questions below. If there's anything that you want to bring up, anything you want Kunal or Raj to answer, I'm sure they'll be happy to take that and answer it.
So let me go ahead and let me get my my screen shared here. Just give me one moment. And you will hear I apologize if you hear a screaming kid in the background. My daughter is only 1, and she picked up common cold, not COVID, common cold. So you may hear some screaming back here, and everything is okay. That's all I'm going to say. All right, so let's jump in and let's get going on what I really want to talk about today, which is serverless. So let's get the presentation mode set up here on my end. Okay, cool. So one thing I wanted to start with, and again, this is not the emphasis of what we were talking about today, but what I want to talk about is very, very high level who we are as a company, who Imperva is. Some of you may have heard of us before, some of you may not. Imperva is a leader in protecting data and all the paths to it. And those paths could be from applications and APIs. We've been hyper-focused in this world for almost 2 decades. Heavily innovating in this space. We are a leader in various quadrants, waves, things like that, for those that pay attention to that stuff. And what we want to talk to you about today, obviously, is around serverless. Now, we spent some time already talking about some of the big evolution that we see today. So organizations like Amazon and specifically AWS have done an amazing job of accelerating a lot of the change or the big evolution that we've seen, whether it's around applications, data, servers, and infrastructure. So it would be probably too much for me to beat this and to probably iterate through all these fine points here. But I think the key message is the stack has changed, right? The stack of what things used to look like 5 or 10 years ago looks completely different today. And it's going to look even more different in the next few years. And so the thing that we want to talk to you all is around serverless. And again, around serverless, we've seen some pretty big changes in the way that applications are developed. So people that are now building out more APIs, more microservices, stitching them together. Maybe they're deploying things on top of Lambda. Maybe they're taking advantage of containerized deployments using EKS or Fargate as a way to sort of instrument and orchestrate a lot of the containers that are being deployed. The neat thing about this is while the stack is changing and as the stack changes, there's a lot of interesting opportunity, both for the good side of things, which is how you build and how you think of sort of changing the stack. And it's always good to refresh those things, but also a good thing for attackers, because a net new area, a new change in compute usually invites people to think differently about how they need to protect these things, because the attackers are thinking differently about how they craft different types of attacks. So we'll talk about some of those things with the OWASP serverless top 10 in just a little bit. So Gitika already went through this, the shift to serverless that we see. The biggest thing that we typically see is what you see in the top left, which is around it being event driven. And that leads to what you see in the bottom left, which is that it allows for these sort of modular design patterns. The idea being that as you maybe spin up a function, you may want it to speak to a specific data store, maybe a RDS instance, or DynamoDB was a great example that you used. Or you may want to have it be reactive to an API gateway, or if someone adds a file to an S3 bucket. All that's great. And it's basically allowing us to write less code, take advantage of the sort of fabric that is being built, and stitch a lot of these services and compute together automatically, right? So instead of having to write integrations with 200 different sources on the AWS side, you just have to understand that these things are fundamentally connected, and it's a trusted connection between these things. However, you have to bring your own business logic to the table, right? Knowing that these are the keys that you need to use, this is what you need to get access to. And so that leads to some interesting things from a security side, and we'll dive into that in a little bit as well. Now, the one big issue that we see as organizations embrace serverless, and again, this is not focused on AWS, this is just a holistic thing in general, right? Is when you think about application development today, traditional applications or traditional apps, we know what that looks like, right? We've had decades of experience as an industry understanding how to build and secure these things. So we pretty much know what good looks like. This is meant to show a more monolithic yet simplistic diagram on the left-hand side of what the world used to be, and in certain cases still is for many applications that probably are deployed today in an on-prem or in a customer managed mode, could be in an AWS or in AWS as an example. But ultimately, the key message here is it's very simple. The idea being that you have a request from the outside that may be going through a load balancer, it's landing inside of an application, the app is doing whatever it needs to do, maybe it's talking to a database, ultimately you get a response back. So a very predictable set of inputs and a somewhat hopefully predictable set of outputs on the other side. So predictable IO is what you see. In the middle area, we've seen over the last, I would say, decade, a lot of organizations embrace microservices. Now, I'm old enough to remember terms like software-oriented or service-oriented architectures. So there's a lot of interesting technologies I can use to date myself. I think my gray hairs do a good job of sort of doing that for you. But the neat thing about the sort of middle area is we know generally that for really large, complex systems, we need to break some of this stuff up, and we need to hopefully build some of this stuff out and distribute a lot of compute among different services. And so we've seen a rise of distributed computing. Dr. Werner Vogels is a great example of a human being who has been sort of pioneering that message for probably multiple decades at this point, right? So we understand the idea of breaking things up into microservices. Serverless kind of adds a little bit more complexity, right? Because now you've got, as Gitika has mentioned, you have these 200 services that are interoperating with each other. And this is just one example, or have the potential to interop with each other. So how do you compose a serverless function? How do you monitor? How do you understand exactly that a serverless function is behaving exactly the way you want it to and is communicating with the services that you are designing it to, right? So you get into some interesting challenges around the usability and the composability, or usability or challenges around the usability of the composability. I know it's a mouthful to say, but that is one of the things that certainly comes up. And of course, that has impacts with respect to security. And the next one that I want to get to, which is the event-driven area, which I love, because from a simplicity perspective, it makes your life much easier from an operator's standpoint, right? Because now you have a lot of pre-wiring that's already done. If this, then that, right? That's effectively what you get with sort of this event-driven compute model, and it's fantastic. But newer types of attack vectors come into play. Because now, instead of having a predictable model that you saw before, which is someone going through maybe the public internet, going through a load balancer, landing in an EC2 instance, now you may have an attack that comes in through a different vector. Could be from an S3 bucket. Maybe someone is adding a file that triggers a function and it takes advantage of a weakness there. Or you have something weak in the overall software supply chain. We'll talk about supply chains in a little bit too. And so you get to some really interesting things because you now have code that is running in more places, and the surface area has changed as well. So a lot of fun things emerge with respect to serverless. And the last challenge that we see is a lot of the traditional tools just don't fit this newer model of compute, right? I mean, if you take a step back, we as an industry have multiple decades of securing applications and securing data, right? Let's just focus on securing applications. Today, how have we done this? As an industry, we focused on maybe deploying solutions at the edge with or at the perimeter. The challenge is for things like Lambda, these things could execute or be triggered by anything. Again, an S3 bucket, maybe a new record shows up in DynamoDB. How do you put a firewall in front of that? And the answer is you don't, right? You don't put a firewall in front of something like Lambda. So things like perimeter security, which the industry is used to deploying for traditional applications, just doesn't fit. The second one is a lot of solutions today that exist around Lambda with respect to security are really around observability, right? A lot of the solutions that we see today are more primed to tell you that they saw functional execution of something, or a function took X milliseconds or seconds, as Gitika demoed as an example, to run or to execute. But they don't really tell you exactly from a security perspective what the posture is of the function itself. What was the risk of that function? And so you get into a little fun gap here where a lot of the solutions may be around performance, but not really around security, or true security, as I like to call it. And then on the last side, there's a lot of scanning tools that have been built up over the years. And I think there's no shortage. I think it's certainly true to say there's no shortage of scanners and composition analysis tools. And those are great, right? No one's saying that those things are bad. They're like good hygiene. You wake up every day, you brush your teeth, hopefully multiple times a day. And scanning tools have their place. But scanning tools will do a good job of raising issues. You still have to go ahead and fix those things. So, right, so you take a step back and you look at traditional security today, and a lot of traditional security just doesn't fit this newer world that is being developed. And we see, as I mentioned before, a lot of organizations embracing Lambda, and a lot of this stuff just doesn't fit. Okay, so we've now covered one part of this, which is the newer model, the newer paradigm, some of the challenges that existing technologies have. But what I wanted to do was go through, and I thought people would benefit from this, which is kind of a high-level understanding of the OWASP serverless top 10. And some of you may be familiar with the OWASP top 10. This is something that if you've been focusing on things like application security for a long time, you probably know a little bit about this with respect to applications. I think it'd be good to actually talk about what's going on in the realm of serverless. You will see, for those that are familiar, some overlap from AppSec. And that's reasonable, right? Because ultimately, these are applications just embodied in functions. So you will see a lot of overlap between these things. So categories like injection, cross-site scripting. Guess what? Those things have been with us for 20 plus years. They're not going anywhere. And so some of those things will come over. But you'll also see different set of things, or things that when you kind of go a little bit deeper mean something a little different in terms of Lambda versus in terms of standard app maybe deployed on EC2, or even some containerized application. Now, I have this sort of Scooby-Doo meme image on the right-hand side here.
It's actually pretty fun.
I was just going to say that it's really funny and actually on point.
I got to ask, I mean, to you both on the AWS side, I'm sure people ask you all the time, because they may think it's like magic, right? They may just think like you write a function and it just arbitrarily executes. We spend a lot of time sort of demystifying that when we talk to people about serverless, and we're like, look, ultimately these things are running, in a AWS Linux instance. It may just be an instance that boots up very, very quickly, or some maybe not. Maybe something else.
We say it's in the cloud, Kunal. We say it's in the cloud. You don't let them know the secret sauce, man.
All I know is you just go in, you write a Lambda function that execute an OS command env, have some fun. That's a really fun thing. And frankly, for those who are on this that have never done that before, I highly recommend you do that, because Lambda is executing in this sort of a Lambda function is executing in a very sandboxed environment for security purposes and security reasons. And I highly recommend, if you've never done that before, it's actually one of the canonical examples. So as Gitika was showing in her demo, there's a lot of pre-built applications. One of them that exists today is the ability to just execute an arbitrary command. So I really recommend you all who've never done this before, spin one of those applications up. And I know it sounds trivial, but like in the case of Python, just run an os.exec command or the equivalent in Node or in Go, and just take a look at standard out on the other side of what comes in or what executes from that function. It's really, really interesting. And yes, it is a server. End of the day, there is a server there that is executing all this stuff. All right, so let's spend some time going through some of the OWASP serverless top 10, just to bring everybody up on the same page. So the first is around injection. And by the way, for those that are just sort of watching, maybe you have us on in the background or anything, feel free to just jump on into the chat and just let us know what you think so far of the content. Do you find this stuff interesting? Do you want us to go a little bit deeper into any one of these areas and categories? We have planned some demos around some of the things that you see. So Raj will actually walk you through some of that stuff in a little bit. But if there are things that you would find interesting, just let us know. We'd be happy to walk you through anything or spend some time on anything else. All right. So let's talk a little bit about injection. Some of you may have heard of phrases or terms like SQL injection before. It depends on the year. Sometimes things like cross-site scripting gets folded under injection. Sometimes it's different. There's remote code execution. Ultimately, the point of an injection is you have code that is executing inside of your application or inside of your function. It may not be the thing you want it to be. It could be something that someone else wants you to run. And the reason for it is your application or your function is operating in a privileged state. And there's been lots of fun cases of injections over the last 15, 16 years, again, dating myself. This screenshot that you see is from one of the most interesting injections or cross-site scripting injections I have ever seen in my life. And I happened to be there on the ground when this happened. But I mentioned before at the beginning, there was a company called MySpace. And again, for there's maybe a generation of people on this call that may not know what MySpace was, and that's okay. It was a social network that basically allowed people to put in arbitrary HTML in their profiles. And there was very limited security in terms of constraining the user input that was provided. And there was an individual, a security researcher by the name of Sami Kamkar, and who basically figured out that he could get JavaScript to execute and ultimately change people's top friends. So he was in their top friends list and change their profile to say, Sami is my hero, and change their about me to do that. So Sami effectively built an amazing cross-site scripting worm. And all it did was it took advantage of multiple things, which was executing JavaScript inside of someone's browser. So it was an injection where as anyone who went to Sami's profile or anyone who had this code in its profile would execute the JavaScript, which would effectively make a call to the back end to update the profile, taking advantage of the logged in user's state. It's a mouthful. So what do we have here is effectively code injection via things like request forgery. And this is just one example that we've seen. We've seen lots of injection attempts, and this is one of the hardest things and where we see a lot of security teams spending a lot of time in the industry today, trying to focus on and trying to stop these types of attacks. Because again, having someone else's code running inside of your function or inside of your application, that's problematic for so many reasons, right? Not only because you can allow for data exfiltration, but it could also allow for all sorts of crazy things, especially when you are in a connected environment where you have 200 plus services that are theoretically connected to each other. So there's a lot of interesting things that could happen in that state. The second one is around broken authentication. And so the really important to mention is serverless functions carry no state. So you saw in Gitika's demo, you'll see it in Raj's demo in a little bit. You write code and that code executes. That code does not keep state in its function at all. You have to rely on a data store, maybe an S3 bucket. If for unstructured data, for semi-structured data, you may be using something else. For structured data, maybe it's RDS. it doesn't matter. The point being that ultimately these serverless functions are completely stateless, which means that you have to be very mindful of things like authentication and how functions are chained together. We haven't gotten to this yet, and so I'll just mention it now. But we do see a design pattern today where you may have a serverless function that calls yet another serverless function, which might call something else. Could be another serverless function again, or it could be another server or another data store. And so how do you keep track of that state? How do you keep track of authentication? How do you have authentication pass through? And so then you get into some fun things around authentication or privacy composition analysis. We see this as a pretty emerging and interesting area in security today. We'll talk about least privilege in a little bit because there's a lot of interesting things that you can and probably should do around that. And I'll show you another fun photo of a dog when it comes to that in just a little bit. And it all makes sense, I promise. The third one is what we see around sensitive data exposure. Ultimately, the crown jewels of every business is data, right? When you take a step back, why do businesses exist? Really, businesses exist to perform a certain task. There's input, output being data, output being data. Why do apps exist? Why do APIs exist? To get people to data. So data is the center of everything. And when attackers are trying to break something, unless they're script kiddies, they're not trying to break something just to break something. They're trying to break something to get access to sensitive information because maybe they want to sell that information or they want to do something fun with it. So that example that we talked about before of what happens when you go into a Lambda function and you pass in a command, env. This is a screenshot of what you would typically see, right? So you may have things like secrets. Maybe you have temporary secrets or temporary data that could be interesting to the attacker. Could even be source code, right? If you're building or writing code in Python or Node, this stuff isn't compiled, right? And what if your source code has sensitive information in it, right? There's a lot of interesting things that an attacker could find interesting inside the context of Lambda execution or a Lambda environment. And again, there's novel things that people are doing. So then you get into how you constrain access or what a Lambda function can and can't do, right? Is it allowed to talk to the public internet? And if so, how do you constrain who and what it can talk to, right? That's just some of those interesting examples of data exfil. As more and more services can be connected with each other, there may be other opportunities to do data exfil. Maybe you want to send it to an S3 bucket, maybe a public S3 bucket that you can pull out from the other side. So again, a lot of fun things that attackers could try and attempt. A4 is around XML external entities. This one's kind of a mouthful, but this has been with us as an industry for years and years and years. Ultimately, this just comes down to bad parsing of XML. There is this thing that exists in XML that allows you, and this is, I'm not kidding, there is an ability for you to pass in, as you can see from the screenshot, a system parameter that effectively allows you to pass in arbitrary things that you want to execute. And this will actually work. If you actually pass in arbitrary XML into, let's say, Java, .NET, even your scripting languages, the XML parser will do what you think it's going to do, even though you don't necessarily want it to do that, right? And so ultimately what we see a lot of people having to do is apply different directives. Usually, like in the case of something like Java, when you have XML that's coming in, you can pass a flag to prevent the execution of these commands from executing, right? But a lot of people don't know that. A lot of people don't realize that you can actually execute commands from something which a lot of people think is benign, like XML. So this is just a fine example. And why it's important in the context of Lambda is we see a lot of people using Lambda today in the context of APIs. You may have an API that's connected to an API gateway. Maybe you have XML that you're allowing from the client to come in. So think about that request flow. XML comes in, the API gateway dispatches it to a Lambda function. The Lambda function then goes ahead and executes the XML. And there you go. You now have a system command that executes on the other side. So if you now chain it back to the env command that we talked about before, what's stopping you from executing an arbitrary command on the system itself? So you get into some really, really fun things. We're halfway through, so let's get to A5 around broken access control. Why do I have a bloodhound here? Why do I have a picture of a bloodhound here? Again, I've been in this industry for some time. On the security side, there used to be this amazing solution. It started off as this sort of open source script or a series of scripts and processes that were developed over the years called Bloodhound. And the idea of Bloodhound was to effectively understand privileged access and how, thinking about least privilege, how you can effectively get to sensitive information. How many hops are you away from that sensitive information? Who must you compromise, or what must fall to get access to that sensitive stuff? And I think this is really important because when we think about A5, which is really around broken access control, it's really around entitlement management. And it goes back to hygiene. How do you know that you've got the right entitlements and the right privileges set up? A good example being, if I have, let's say, a Lambda function that's communicating with an S3 bucket, we sometimes see a lot of people just be very generic and say, yeah, my Lambda function can talk to S3. That's not enough, everybody. Like, that's not enough. Like you're basically are saying that you're okay with reads and writes and deletes, right? So like, you need to go a little bit tighter than that. And it's not just the fact that you want to constrain it to a bucket. Great, that's good. But you also need to constrain the commands on the operations that you're going to allow. And so this is a really important thing, and making sure that you've scoped this properly. And again, you then get into the complexity of, over time, when you do go all in on something like Lambda, how are you constraining and monitoring the permissions as things change in the environment? And again, there's just big problems that you end up having in the context of having thousands and thousands of services. I think the key message here is, if you really want to get your arms around this, to try and set up processes, as well as making sure you've got the right frameworks internally as a business from the very get-go, right? Yeah. Don't let this get out of control. Try and solve for it at the beginning when you're building out Lambda, and making sure that security is certainly part of that process. Again, to misconfigurations, people always talk about things being insecure. It's not AWS, right? It's all over the place. People will always point the blame and point fingers at other people. Guess what, everybody? Misconfiguration is still an issue. It's still a big problem. And again, you take, for example, that S3 example I mentioned before, we see a lot of times breaches and things truly related to things like people not having the right configurations, the right policies, the right security in place between services, people not locking things down enough. And so what happens when you have a lot of things open? They're going to be discovered. Attackers will figure it out, right? And so misconfiguration is still a huge, huge issue. There's an element of misconfiguration that needs to be applied from developers, but I think a lot of misconfiguration and solving for a lot of misconfigurations needs to be the sort of confluence of security and operations teams working together. There's only so much as a developer that you can focus on with configurations. As developers, you may not own the operating environment for how your function executes or how the services communicate with each other. You're responsible for writing code, but making sure that you supply things like a high-level threat model of this function should only talk to this, I think would help people. So to the developers as you think about going deeper in how you might be able to better help your security teams, thinking about supplying a high-level threat model to help the overall team help scope those things. Cross-site scripting, we already talked about the SAMI worm over here. The canonical examples of what you typically see with cross-site scripting are people doing script alert one or script alert owned or whatever it might be. There's a lot more to that, right? Which could be arbitrary execution. There's two types of cross-site scripting. There's XSS that reflects and execute back in the browser immediately. You typically see that when you put XSS into like a query string parameter. You send the link to the victim executes the JavaScript, and there you go. That's reflected cross-site scripting. You get persistent cross-site scripting when the cross-site scripting that you put in is going to basically be saved in a data store, and then it can be reflected back later on. And so there's some significant repercussions that can happen from that. So that SAMI worm that we talked about, that was a persistent injection. There's persistent cross-site scripting as well. And again, the big challenge that we see here is the surface area has changed, right? And because the surface area has changed, there's now multiple entry points to get in things like cross-site scripting. And of course, things like persistent cross-site scripting becomes a really big issue Whereas maybe for traditional applications, they really weren't, because you had more of a predictable model and it was mostly reflected. Here, you do get a lot of persistent cross-site scripting. A8 is insecure deserialization. So a lot of other people don't realize, and again, for the app folks on the call, you may be already familiar with things like data serialization and deserialization. Think about it as moving something from one format to another. You typically see this today when, let's say you have a blob of JSON or XML coming into your application. You need to parse it and convert it to an object. Maybe you want to take a JSON blob from, I don't know, maybe you're invoking DynamoDB, you get a JSON response back from that. And instead of having to parse the JSON response directly, you just want to convert it into an object that you can enumerate over and quickly get access to things. In there lies data serialization and deserialization, where you're taking a stream of data, you're deserializing it into effectively an object on the other side. Serialization would be encoding it into the stream of bytes. Deserialization would be going from bytes back into the object. So over the years, there's been a lot of people, a lot of open source libraries, a lot of scripts and functions where a lot of people have not done the right thing from a security perspective with serializing and deserializing. And this has led to things like remote code exec. Some of the biggest data breaches and some of the biggest security issues we've seen over the last, certainly over the last 5 years and possibly over the last decade, really is around people taking advantage of this overall supply chain and going after serialization and deserialization techniques to inject code or to do whatever code execution they want. So this is a really big one. And this gets us to A9, which is around the software supply chain. I couldn't help myself. This is my favorite XKCD comic as it relates to security. So I'll just read it out. All modern digital infrastructure at the top, and you can see a bunch of abstractions, all hinging on this one tiny, tiny little block. A project some random person in Nebraska has been thanklessly maintaining since 2003, right? So this is the software supply chain of what it really looks like today. You have a lot of great open source that people write, and over time, significant projects will end up using those things. And that's great, right? Because we don't have to reinvent the wheel. GitHub estimates somewhere between 85 to 97% of enterprise source code relies on open source libraries and dependencies. And that is a really big deal for things like serverless functions, because to the example of Gitika that you just showed us, right, where you were building up a couple of simplistic Python functions or functions expressed in Python, you brought in libraries, you brought in third-party code. How do you know that third-party code didn't have vulnerabilities? What if the third-party code that you brought in did contain vulnerabilities? Maybe you're using an API, or you're using something to get access or being able to make a third-party call. Again, those things could be taken advantage of over time. And again, you go back to like the biggest issue that we see is a lot of people rely on scanning and composition analysis, and those don't really fix the problem. They just tell you that, you know, you have some bad code. You still have to go ahead and fix those things. And so examples of dependencies doesn't have to be a third-party library. It could also be the language runtime, right? Your application depends on Python. Your application depends on Node.js. So what if the attacker finds a critical vulnerability or a 0-day inside of those language runtimes, right? Those things are susceptible as well. And we've seen that over the last few years where a lot of attackers have gone after Java. They've gone after PHP for decades now, right? PHP has been mercilessly attacked, right? And not because PHP lacks good security. The PHP security team is excellent. The challenge is a lot of people use PHP in the world. And so attackers realize that if they can go after a widely deployed technology, they can do a lot of harm. And so it's just important to mention and call out that the language runtime is equally part of this. All right, we get to the last thing in the OWASP top 10 here, and that's around insufficient logging. So insufficient logging, I think, is certainly interesting because, again, you think about the composability of a lot of serverless functions today. How do you know that the function did exactly what you wanted to do? On the Imperva side, we use a lot of serverless technologies. We've been using Lambda for a while, so I can share that we had to build a lot of monitoring around these functions just to ensure that the function did what it needed to. And when things went sideways or if something didn't do what it needed to, we also had enough visibility into those things because, again, the moment you start to connect this sort of distributed system and very distributed architecture to critical business functions, you need to know when something is working correctly or something fails. And also from a security perspective, and again, it's not just about from an OpEx side knowing exactly what's going on, but it's also from an audit and compliance perspective. If you are building a function that's doing something absolutely critical, right? Maybe you are building a function that's focusing on privacy. Let's say subject right requests. When you have a request that comes in to delete consumer information all over your environment, you may be writing something in a Lambda function, and that's totally reasonable, right? You could write something in a Lambda function that says, I'm going to go ahead and delete this from RDS, this from DynamoDB, blow out a file in S3 or archive data. The perfect use case for using something like Lambda. But do you have the right audit around that function's execution? So should tomorrow your auditor or someone comes in from compliance and risk and says, all right, Gitika requested her information to be deleted. Do we know that that information or that information was handled, that subject right request that came in was handled appropriately? And do we know that information was sufficiently deleted, right? How do you keep track of all of that? And so that monitoring, that visibility into the overall process is just absolutely critical. All right. So we covered the big change that we see from a compute perspective. We actually walked through the OWASP serverless top 10. Hopefully the fun images gave you something interesting to think about and broke up the seriousness and added some lightness and some humor into what we see today. And all of this is what led us at Imperva to build out what we call serverless protection for AWS Lambda. We actually, again, we were an early user of AWS Lambda. We believe that this is just a tremendous and amazing opportunity for people to build and express themselves in functions. It's just a totally different way of doing it versus writing large monolithic applications. So we saw this space, and we've been watching this space for quite some time. On the Imperva front, we've been focused on building things like firewalls for 20 years, right? We're the experts in building things like web application firewalls. We understand what it means to build something inside of an application. But building something for Lambda is just totally different, right? For all those reasons that we just talked about. A lot of traditional compute just doesn't fit protecting a Lambda function. You need to do something different. You need to change the way that you think about security and also different types of security controls. So we actually partnered with AWS. So we worked really closely with the AWS Lambda team. We came to them and we said, listen, there's got to be a better way that organizations can try to protect themselves. And we got to find a way to do this in a way where organizations don't have to spend an inordinate amount of time to effectively go through every single function and change lines of code and do all of that, because that's just intractable, right? We've been trying to do that for 20 years in general AppSec, where security finds a problem, they go to the dev team. Some of you may already roll your eyes when I say this because you know what this pain is like. Security teams find a problem, they go to the development teams and they're like, here you go, here's a laundry list of things, go fix those things. Well, it takes a lot of time and it takes a ton of effort for organizations to fix a lot of those things today. And the same thing is true could be true certainly for something like Lambda. So we got together with AWS and we're like, guys, there's got to be a way where we could bring the intelligence of understanding what's going on inside of a function, but really focus on the serverless top 10. And so that's what we partnered on, and that's what we came with. So we were a partner with AWS specifically around deploying security via a Lambda layer. So no code changes to your core functions, effectively being able to provide security and security protection, not just visibility as to what's going on, but effectively core security. So let's say you want to stop an injection attempt. Maybe you have a remote code exec or a lateral network call, or maybe you get triggered from an object that goes into an S3 bucket. We built basically a Lambda layer that will snap right into your stack today. Again, no code changes. And what it wants to do is effectively provide protections. And the way it works is really cool under the hood. Take, for instance, things like Node and Python, just two great scripting languages, dynamic languages that a lot of people use today. The way us as a Lambda function works is we get injected into the runtime effectively via the Lambda layer. So you have to do an inclusion at the top of your function that says, I want to include the Lambda layer in certain cases. In others, you just don't have to because the Lambda layer is smart enough for that dynamic language to just get inserted. But the neat part about it is we will just automatically hook the runtime. And what we mean by hook is when we see common, let's say, interfaces that are used, let's say database calls or database drivers or things that are used commonly across all application runtimes, we'll basically put ourselves directly there so we can see the event before it executes. So think about it as a way of building a firewall, but putting a firewall inside of your application or inside of your function. That's what we built. And so again, no code changes. Raj will walk you through some of that. Again, you can take the data and really put it anywhere. It could be back in CloudWatch, it could be back in SIM, could be in our own platform for visualization. Raj will walk you through all of that as well. We're really excited about the fact that you can just take raw output now. And so you go back to like A10, which is insufficient monitoring. What if now you had full monitoring from a security perspective and full audit from a security perspective inside of all of your functions, and you could predictably get it out to a single place, funnel it into a queue, and then do what you need to from a compliance perspective. So shining a bigger light onto anything and everything that's going on. The way we think about things when we were building this was we broke it down into 3 categories: attacks, injections, and weaknesses. This is just a high-level spattering of what we came to market with today and how it works and what it does. So this isn't feeds and speeds. This is really showing you that we can monitor for all of these things. So things like cross-site scripting, broader injections, command execution, things like deserialization, and vulnerable dependencies. And you can just layer all of these things together. And we do that. And Raj will actually walk you through a demo. He'll show you how it's composed, how it's all set up. Again, we're really excited about this because from like a value perspective, we understand that Lambda is heavily used. It's going to be even more used. And we wanted to give teams an ability to basically deploy security that's going to travel everywhere the function executes. It's going to be stateless, and you're going to be able to modify and configure it in real time. So should you want to go from a monitor mode to a protect mode, should you want to enable a module for cross-site scripting or disable something like SQL injection, it's real time. And the neat thing about it is that it is incredibly fast and it's incredibly performant. So we'll actually walk through all that stuff as well. Now, high-level architecture. Oh, yeah, go for it.
I'm not sure, Ulrich, if you posted that question, but go ahead and put that for Kunal. Yeah, go ahead.
I didn't want to cut you off, Kunal, but I'm actually, while you showing all this type of attacks, I'm actually really interested in knowing how can Imperva protect my serverless application against, by example, denial of service, and by example, financial resource exhaustion. By example, if I have an application when in the cloud, how can I also protect my application against DOS attacks, right? Which is something really common, right?
Mm-hmm. Yeah. Okay. So there's two or three types of denial of service things if you kind of break it down. One would be volumetric at the network that comes in. So like if you think about the ingress denial of service, which is basically a botnet or someone that wants to knock you offline, right? Gets enough compute and network capacity to just throw at an application and or a service. The way you solve for that is at the edge, at the perimeter, right? You want to block all that stuff as far out as you can. And so that's where a firewall-like technology makes sense. What we do at the edge fits into this world. Certainly what AWS does as well for organizations that want to stop DDoS attacks at the edge. It's the right thing to do, right? You try and solve for that. But then you get into what you just said, which is the sort of secondary type of DOS attack, which is usually someone kicks off a code injection or someone finds some part of the application stack where they can just do whatever they want. Maybe it's a laughing attack. Like there's an attack called a laughing attack as an example. Or let's say someone wants to open a connection to a database and they just keep it open for a long time. Usually the root cause of those things is specifically from code exec. And that's an element of what we can provide protection around. We're not going to, with serverless protection, do volumetric DDoS like that. That's going to be solved for at the edge. But what we can solve for only to a degree, because again, there's other types of denial of service things that you could see in terms of resource exhaustion. But if you get a denial of service that has been executed or triggered by things like code execution, we can absolutely see and stop that for sure.
Thank you.
The last thing that I wanted to share here, and then I think we'll turn it over to Raj, who will walk us through a really cool set of demos. But at a high level, this is the way we kind of think about things, which is, let's say you have maybe a request that comes through an API gateway or something that gets triggered via an S3 bucket. The way we work is we build something that's completely air-gapped and something that's pretty autonomous in that the security itself, the protection itself, is happening within the context of a Lambda function. So the engine itself for how to protect and deciding what to block, that's not leaving your environment. And that's really, really important, because that won't work from a performance perspective, where again, you can get into sub-second billing, right? And so you want to make sure from a performance perspective that this is going to adhere to and do what you need it to. And at the same time, you can get the logs out of these things and really push it anywhere you want. And this is just one example architecture that we see today. So again, we covered a lot of intro material there. Raj, I think it'd be great if we hand it over to you and you can take it from here and start to show folks, a high-level series of demos, and we can walk through it and talk through what exactly is going on. I know you designed a few really cool demos to show people, some of them that you see here in the diagram. So I'll pass it over to you, and let's walk through it.
Yeah, sounds good. So let's start with something very simple, right? I want to basically give a version, take it off from where Gitika left in terms of a sample serverless function. And even start from this console before going to the product and stuff like that. I want to just start with demonstrating a very simple function. This is a super gullible function, similar to everything that we spoke on command injection, right? All this particular command helper is doing is to take a set of arguments and run it inside as OS commands. Super gullible, not the right way to do things, but it's just a demonstration. What we're trying to do is just executing that with os.open and reading the output and passing that as as a part of the JSON response. So if you look at what the function itself is trying to do, it's just showing the output as a result and then also the event itself. So I'm going to test this out with a sample not so harmful ls function. I have a sample API gateway event simulated here. This is all that it's looking for, which is a query string parameter with a command. Let's just test this out, right? And this has no predictions, nothing of that sort. I'm just executing the function as is, like an end user. So here the results, it says lambda underscore function.py. So that particular directory had only one file, which was lambda function.py. Okay, well, I'm an attacker and I've seen this, right? I know what exists in that particular directory, and I know I've been successful retrieving that. So let's try a different kind of a command, right? I know this file exists. I'm just going to try and cat it now, right? So let's do this, and then let's save changes and test the new event. So really, this is now spitting out every single thing. It's just doing it line by line to show what we have within the function itself. It's really interesting because it started out as a super not so not so serious ls command, which is often actually used for legit use cases by developers. So now we are off to printing something with us, printing my source code itself. This could then be used to exploit even more, because this can expose some weaknesses in the way my Lambda function operates, and even more, right? We could do that. I'm very tempted to go ahead and test another event with, say, a print env over here. But that's going to expose my own AWS secret, so I'm not going to do that. But I would really encourage others to just try this out and show how things are going. And like we discussed, this is a sandbox environment, so a lot of the defaults are actually pretty configurable. So one of the default is actually printing out the AWS secret key. So it's kind of where it is, and it's very helpful from a programmatic perspective. So I'm just trying to say how we can go from a very simple command injection to going to really very serious stuff. You could start printing out pass WD or something of that sort to even go a little bit further there.
Raj, you could if we wanted to, you could just swap that command out for what we were talking about before, right? ENV, and then and do an execution,
Yep.
right?
I could absolutely do this. It's gonna expose my own our own secrets and stuff like that. So yeah, this is really what all it takes. I do a test and it will print out every single environment variable that I have in the context.
And I just wanted to pitch in one thing. If anyone's actually interested in learning about the product itself, you can actually request for a free trial. I put it in the Twitch channel. So go ahead and do that, and you can always come back, test out these things that Raj is walking us through, and test out the product.
Thanks.
Yeah, Ulrich, you wanted to say something?
Yeah, I like the fact that Raj noticed that he could have shown his keys because we're talking about security, and then here we go.
Or this was Raj's test right there, and Raj passed.
Yeah, you did.
Yeah,
Trust me, I would have said something.
Absolutely. So and this is true for even more, right? Like you could do path traversal. For example, I could do a cat on slash, do an ls on slash, and try to go through each and every directory and stuff like that. I mean, so the idea is once we open up command line, we expose a lot more than we would have liked. And this is basically just a sample application. I wanted to go through this even before we start showing off the product and saying what protections happen and stuff like that. And most Lambda functions are this short. Like, I mean, at least based on our experience, happy to get more inputs if we think otherwise. It's usually less than 100 lines. It has a very clear definition of what it's supposed to be doing. And that should kind of be it. Like, it should really not be doing any rogue things to start with. So introducing our serverless protection product, right? Like, so this is the management console. I just wanted to start with the experience of adding a new account, onboarding functions, adding protections to them, and stuff like that. And now that we've seen one gullible function, let's go ahead and see how do we get to add protections there, right? So I have one account that is onboarded right now. So we have the role on and stuff like that. Just to be able to create, add an account. All we do is to run basically a CloudFormation template that creates the IAM role for you. So once you press create role, it triggers the CloudFormation stack with the right variables to be able to set this up for you with the right level of access. So we do need Lambda read access for starting with, say, discovery and trying to understand where these functions lie. And also write access to the Lambda layer itself to be able to invoke it automatically. So we pre-populate these things like external ID and stuff is important. So once you say create stack, you get that thing going, you get the formation going, and in output parameters, so this may not succeed because I already have added the account. I'm just going to go ahead and do this anyway. So inside outputs, you would have a couple of parameters that comes out once the stack creation is complete. The two would be external ID and the role on itself. So that just needs to go in here. And you've added your first account on Imperva serverless solution, serverless security. So this scans for functions automatically. So you go from here to being able to see this. So we have a bunch of functions. So it's not the prettiest looking screen ever because we have our own naming conventions and stuff like that. So we have about 100 something serverless functions that are within these accounts. So, and currently we support Python 3x and Node 10 plus. That's our support compatibility. So you could see some of, 3.7 plus. You could see some of these are actually not supported. So the idea here is very simple, right? You have a function, and like Kunal mentioned, the way we are embedding protections is through a Lambda layer. The Lambda layer, like he mentioned previously, it's just hooking at the right places within the runtime itself to be able to see what's going on when it's, say, trying to connect to a database layer or when it's making network activity and stuff like that, to be able to either observe or intervene in each of those activities. So each of these function can have an associated configuration. And you have the enable flag, like, you basically associated with the configuration and just switch the enable flag, and you have already enabled serverless protection on this particular function.
Raj, can you do me a favor and can you walk people through, like, when you hit the enable function, what exactly is happening? And the reason why I think it'd be good to do that is there may be people on here who are paranoid about, like, when you hit a flag like this. I would be. Explain to people what is actually going on under the hood.
Absolutely, I could do that. So there are a couple of things, and again, all of this can be completely bypassed from our UI. This is just a ease of use functionality. If you have, say, Terraform based work, functionality that you already have within your existing policies, you could totally use that to do this via, say, some sort of scripting.
And CloudFormation as well, right? So it doesn't have to necessarily be Terraform. If people wanted to leverage things like CloudFormation, other sort of really interesting sort of CI/CD tools, this is all very portable, right?
Absolutely. Thanks for bringing CloudFormation too. So all we're doing when we do the enable flag is two things. One is we attach the Lambda layer itself. So let me bring this one up, right? So you now see something so AWS has this amazing thing called a Lambda layer, which basically gives our piece of code the ability to come up first before the function is invoked. This is really important when you're doing cold start. So the serverless protection Lambda layer is able to observe things before it starts serving things on the request. So our entire IP, or the product itself, is just this particular Lambda layer. That's all that there is. And like Kunal mentioned, this is air gapped. It is able to take decisions on its own. It doesn't really require like a learning or to be able to talk to a cloud engine to be able to make a decision and then figure what to act on top of. So what we have here is Imperva Rasp Lambda Python 3.8 layer. We have our own version and then the ARN for it. That's really all that there is with respect to product. So it's super portable, and you could use it in any of the orchestration mechanisms that you currently do. The UI is one simple way to do it. So, and I said the UI does, when we say enable, it does a couple of things. First is it enables the Lambda layer. The second is it sets a few environment variables. So I'm going to leave, for example, the API key, and then we have a secret and all of that's underneath it. And it also picks up configuration through a microservices architecture that we've built within the SaaS platform. And we're going to talk about the configuration. So it's like any other configuration, has all the knobs and buttons that you can turn on to be able to change the level of protection or to figure out where logging should go and stuff like that. And Kunal, or if there's any questions or something like that in any of these pieces, also feel free to just let me know.
So,
Other than
Raj,
that,
I had one question. Yeah, so you deployed a CloudFormation template. So does that cover like all the regions, or do you have to like deploy one for every region
great
for
question.
protection?
So it depends on where your function is. So say, for example, your serverless function is within is deployed within this particular region. Like in this case, my function is in Northern Virginia, and you're making copies of these across regions. They're essentially different functions. So, and each of the function needs its own Lambda layer. So yeah, if you're making copies across regions, it would require duplicates. Yes.
Okay, and once it's deployed, then you would actually go into the UI and then enable it is when it would kick off.
Correct. Or
Okay.
you could also set up, like, say, automation scripts. We know some customers have expressed interest in saying, hey, any new function that is created, we want to try and make sure it has at least like a basic vanilla config that is there. So you could, for example, trigger a Lambda function that goes and attaches this Lambda layer as well.
Nice.
Okay. So going back into configuration, right? So you have a config name, app name, and this is all just for naming. So you could create a number of configurations and assign it to any number of functions. So this is a one-to-many mapping. You could reuse the same config for several functions, as I'm going to be doing today as well. just for the demo. You are able to tweak, like, for example, how noisy you want the logging to be, or if you want only the critical events to show up here. And we do that based on what we see as severity. For example, deliberate SQL injection or deliberate command injection would be a critical event, versus say some kind of content parsing based errors, like especially on HTML and others, could be a medium. So you could change. I mean, you could figure out what level of logging do you need. And for Lambda, we always recommend logging to console, so it shows up on CloudWatch. We can also see how that works as well. So this
And
is
Raj, the
yeah.
other thing that's also worth mentioning, when we talked about like insufficient logging, if you kind of go all the way up to minimum event security, one thing that we've seen some organizations do is go maybe to like an info mode or go into all. And the reason for it is it basically will tell you everything that's going on, even if we didn't take an action. So for instance, let's say you had an OS system call or you had a network call from your function. If that was a totally okay call to happen, right? You may have valid execution of any one of those things, but you want to know that those things did happen. You can get that output because by being instrumented inside of a function through a Lambda layer, we will just tell you that those things executed. So if you want to go back and know for a fact that, let's say, a subject write request, maybe you wanted to delete something from a database or you wanted to make an OS system call, if that actually happened or not, we'll just tell you, right? We'll tell you right there, and it'll be in a JSON blob, and it's up to you then to decide if you want to store that log somewhere. It's up to you, or you want to discard it. But we do give you a lot of visibility as to what's going on.
Yeah. So so this is the minimum event severity, like Kunal mentioned, and it is actually okay to have more logs than less logs. So yeah, that's true. We've seen a lot of our customers use this on all. This is all about, like, masking and how you want your logging to be and stuff like that. For example, you could actually log environment variables if you needed to, and I've turned that off by default over here. Or, like, you could, for example, log these and then use any of the masking policies if you don't want sensitive information to come through in these logs, because different personas could be accessing these logs as opposed to those that have clearance to be able to do this.
So to what Ulrich brought up earlier, if we were really worried, and if an organization is worried about, let's say, environmental variables like secrets or things like that making their way into logs, but they do want to capture some of the environmental information, they can absolutely do that, but they can create sensitive data masks if they wanted to, or custom data masks around their application. So it would be pretty straightforward to make sure that that information will be redacted. Because again, in these really complex cloud-based environments and build-outs that organizations have, you don't necessarily know when it comes to things like CloudWatch. You should know, but sometimes there may be other people or other audiences that shouldn't necessarily have the ability to see everything. And if you've got a bunch of stuff funneling in there, you certainly need to make sure that what you have in there is not going to leak or share sensitive information, maybe about the environment or certainly about the end user information that might be flowing through something like a Lambda function.
Yeah, so we do have pretty elaborate masking policies. You could use custom regex as well, like Kunal mentioned. This is about diagnostics, just to see, just to write events and to be able to make sure that the plugin started well and stuff like that. And so all serverless functions, you do have access to /tmp. Like, again, it goes back to what we saw previously, that these are actually underlying microservers that are serving these. So they do have a file system that can be also exploited potentially. So in this case, we've written it to like a TMP directory with the bunch of events that whatever it took to be able to attach the plugin. And then we have HTTP protections, kind of relevant if your function is front of an API gateway. Some of it would be handled by the API gateway itself, but if there's more events that RASP sees in front of it, a lot of this is applicable. Same with security headers. And again, I'm not going to go over each of these protections. And if you would like to try out even more elaborately, the product's always free, free to try until the end of the year, as you'll probably see in the description as well. So I've, for example, today turned on monitor for content injection protection. What this means is it's not really going to block or throw a trace back or something of that sort. It is simply going to let it go, and so it doesn't intervene with the application, but it logs an event on CloudWatch and say that, hey, this particular command I happened, and this was the entire context, and we'll be going over the event structure as well over here. Same for path traversal. In this case, I've disabled, and for SQL injection as well. So we have top relational databases that are actually supported. You can have specific security policies with each of the databases that can come through. Again, the usual is obvious contradictions or tautologies and stuff like that you can monitor for. We do use grammar-based parsing to be able to do this through Langsec technologies as well. So again,
So,
yeah, go
Raj,
ahead, Keith.
correct me if I'm wrong. Can this also be used for like meeting compliance needs like GDPR or like protection of any PII
Absolutely.
information or health information?
Yeah. So one of the top requirements with compliance is, knowing when there was a data leak and to be able to get those things logged at the right times, the right places. So it starts from there. So even if you have it all in monitor mode, but you're controlling access to who was able to access the data through these serverless functions, it helps in
Right.
that way. But if you're looking for a much more holistic solution that is checking every single access to the database and what kind of data that it went through, I would recommend, for example, our database activity monitoring or database privacy kind of products, data privacy.
Got it. Thank you.
So the next in line is, again, network activity protection. For example, you could have a data science based app that is running like a proxy server to be able to access some things, access URLs that they're not supposed to be accessing, but you could basically hide behind a particular application to be able to do that. Or let's say there's a command and control server that is reporting back home with all the exfiltrated data. And you want to make sure the app is not talking to servers outside of a particular subnet or a specific list. You have that level of control within the app as well. I think this is important to bring up because if it was a traditional application, you would have, say, for example, a web application firewall that would be able to give some of these kind of protections. But in serverless, it's a little bit more less pronounced, and for example, the boundary issues that we discussed makes this wanting to actually do this at the plugin level in the application itself. And again, for weak cryptography, if you're using any of the older algorithms and stuff like that, it could alert. So that is everything on the application config. Kunal, is there anything that you wanted to add? Or
No,
we'll just
I think the key thing is there's a lot of capability here. And
Yep.
to the folks that are watching, a lot of the capability that you see here comes from a product that myself and my co-founder started building up in the early 2010s. So in around 2013, we started a company called Previty, runtime application self-protection, or what is now known as in-app protection. And we really focused on putting security directly into an application. And so as we saw a lot of organizations embrace Lambda, we basically said, is there an opportunity where we could take the decade that we've invested in building up security inside of an application and make it fit a function? And so through the partnership of working closely with AWS, understanding how people are building and deploying, let's say, Node or Python functions, that's where we effectively took a lot of these capabilities. So you shouldn't have the impression that these are just brand new, bleeding edge, has never been tested before capabilities. Some of the biggest companies in the world are already using this at scale. So extremely large organizations, government agencies, things like that all over the world are already using these types of security protections, the exact ones that Raj is walking you through today to protect applications, APIs, microservices, and even organizations using this for protecting serverless functions as well.
Absolutely. Okay, so like you said, this is a screen full of bells and whistles, and a bunch of buttons as well. So I'm just gonna start with this default configuration. I'm gonna save this config. So this is config saved, and like we said, we could have multiple configuration and assign it to different kind of functions. So for our serverless demo function, I've assigned this config and I've already enabled this. So let's go ahead and try everything that we tried on the command line, on the command injection part previously. So let's get into code testing. Uh, I hope this, yeah, this is okay too, or I'm just gonna switch it back to ls. Uh, let's do a test. And remember, our configuration is currently on monitor mode. So this did succeed. It did go through, and it showed me that this is the only file in that particular directory. Let's actually get into CloudWatch logs to see what happens there. Uh, okay, so this is the one. This was previously. Oh, this one comes. This is the latest one, I believe. Yeah, 356. Okay, so
Raj, I love how you're doing the UTC time conversions. And for those that don't know, Raj and I would ordinarily be in the same place in the same time zone. Raj had a family situation that came up, so he's actually in India right now, and so I love the fact that whenever we're coordinating meetings or doing demos or things, he's effectively doing like UTC offsets based on his location, and I always have to remember that. So good on you, sir, for doing the offset.
thanks, Kunal. Yeah, so we're seeing the and remember we spoke about severity of events as well, and this is an informational event. Let's go see what this is. This is basically saying everything that came in the config. So when you have informational level severity mode, you're overlogging for the most part, which is good, like because storage is cheap, and but what is actually important is to be able to store information. So this is a dump of everything that went to the config. Remember this sophisticated screen with configuration that we saw. At the end of the day, this is a JSON dump, and like we've actually seen customers use this, like just download this as a JSON file and edit it in like their own editor and so on. So that JSON is what we see here, very portable. There is the other informational events, which is basically a statistic talking about, like, for example, if there were any blogs, any what were the kind of events and stuff like that. So that's your informational event. So we do have another high severity event in here. So here there's an ID to this. It says this was allowed because based on the configuration, it was in monitor mode. This was a command injection event. It did not log the environment, and these are actually the keys that we see on the environment variable. The config path, AWS secret access key. So one of the reasons I didn't do the print env. So this is all there, but it's not logged. And again, if you want some of this information, for example, the config version to show up and function name to show up, you could totally use masking policies or even filter the particular environment variable that needs to show up in the logs and not log every single environment variable over there as well. So all Lambda functions work from where task. The actual file would be where task lambda function.py. It's giving you the entire stack trace of where this particular thing happened. This was on line 15 of the Lambda function, which was inside the CMDI helper. And we're going over what happened, what was the direction of the call, and for example, this was the bad URL that came. And our function basically was processing everything that came as CMD is equal to within the URL. And there's even more headers, and like for example, if it's coming from an API gateway and others, you will have a lot of these headers populated. You could customize this as well in the caller to the function. So what we get to see here is there is a lot of context, either both for going and fixing this if you wanted to fix it, or to be able to put it in protect and say that, hey, you know what, I do not want to do this. I'll just turn on protection and kind of forget about it. Or like, let's just say there's an event that happened and you want to do forensics and investigation. You have all the data in here to be able to go back and revisit it. So now that we are yeah, sorry, go ahead, Gitika.
Yeah, I just had one question. So, say a Lambda function is working fine up until yesterday, and you have everything in place, like you have the event security to say critical, so everything is being covered um, by the Imperva serverless protection. What happens if, say, there is a critical event that is locked? Like, what would the next set of events look like? Will there be a notification sent out, or how would someone get to know that there's a critical security?
That's a great question. So couple of things. One is if you're in protect, you've already been taken care of, and this is FYI for you. But let's say you're on monitor, so you have this event in CloudWatch now. So CloudWatch, again, a great platform, has n number of connectors. So for it, we do have the ability to connect to our Imperva Sonar platform as well, which basically aggregates the events and shows it to you in a platform that you can consume it on. Or let's say using any other SIM application and you want this to go to your SOC or security operations kind of teams, you could totally do that as well. Like for the top SIM providers, say Splunk or Elastic, they all have CloudWatch connectors. You just need to connect them and make sure it falls into your existing workflows. And from there, the possibilities are endless, right? Like you could connect it to a Yuba if you wanted to and have overlogging here. Or you could even do, for example, SOAR kind of workflows and figure out who actually needs to take care of this once it has happened. And we've seen this being done even for protected events because customers care about this thing not happening, or at least having a level of forensic to be able to see that why this happened in the first place, even although it was protected.
Got it. It makes sense.
Cool. So let's turn this on to protect, right? Like we previously had command injection, protection, and monitor. I'm going to change this to protect. And again, all configurations update dynamically. So once you change this, the association, every function that has the serverless test config picks up the latest config automatically. There's no plumbing, shipping files around kind of stuff in here. So let's go ahead and test this function once again. So this is the same event that we have. It's a post, and it's trying to do a command injection now. Let's see what happens. So here it threw a RASP exception saying executable not allowed. Again, this could be handled in any way that you wanted to. Like, for example, if you wanted to do a try catch or something of that sort and show a more elegant message, you could do that too. But in this case, it's just an exception. So most RASP exceptions are in this format. And for example, so now this is returned with a 500 internal server error. Or you have, for example, at the caller level, a more gracious way of handling 500s or anything of that sort. So again, it's a generic exception. You could handle it in any way that's possible. Usually, once the caller throws a 500, it cascades down very well across the application, even if it has, like, say, a front-end UI that is in turn calling the API gateway and then the Lambda function. It all works backwards the moment it shows a 500 to be able to give the appropriate error message.
Hey, Raj, just to interrupt a couple of things. So in this particular context, we're looking at OS system command injection or code execution that's being trapped, being caught, and being prevented. But you'll all notice there is additional metadata in here from the originating request. So Raj, maybe if you can kind of scroll down, because some folks may already be seeing it in the chat or on the stream, but you can effectively see things like we have like the user agent, the header string, things like that all are supplied with the call. And so the nice thing about it from like a security perspective, so Gitika, you brought up like the risk and security angle, specifically from compliance. What do you get out of this? Well, now you actually have a control that's living inside of the function and isn't just protecting the function, but all the IO around it and giving you the visibility of how it was called, who called it, the call stack associated with it. And we think that that's a pretty big deal, right? That's a pretty big deal in terms of being able to now go back to a security team and tell them, listen, here's the line of code that executed within the function. We'll show you the stack trace, but here's all the input that came in. So should you want to go ahead and sort of recreate this in a staging environment, or if you want to go back in and do a deeper dive to understand the context of how we may have executed down this particular code path, well, great, now you have this whole payload and you can go back. So the use cases are definitely there from like a security and an audit perspective, but they're also certainly there from like a development perspective where now you want to troubleshoot. Great, here it was. Here's everything that came in to said function. And again, if you're practicing, or you're leveraging things like CloudFormation or Terraform or whatever it might be, you should theoretically be able to stand up the same exact function, maybe in a sandbox elsewhere, maybe in a different environment, and go ahead and sort of test the payload against it to see exactly what's going on. So like what Raj has on the screen here as an example in CloudWatch is the full stack trace of the event call. So we can show you like specifically within the function itself, like we saw execution on lambda function.py line 15. And you can see the stack trace here, which shows the bootstrap, the runtime of AWS Lambda, right? So we know that they may not be sort of original versions of the language runtimes, right? So these could be hardened and secured versions of Python or Node, whatever it might be, and the full stack trace as it goes up. And again, you can control it. So if you want to stack trace that as 10 entries or 100 entries, certainly you can do that. Of course, at that point, when you are interrogating the full execution or the full stack, there could be some performance implications there, right? So certainly, I think a more shallow thing is probably a little bit sufficient for a use case like Lambda, where you don't have these really long chains of invocation. Nonetheless, what's really nice about it is everything is all in one place. Everything is all in one log event like this. So you have the HTTP information, you've got a bunch of environmental information that you see above, all this coming out in one place. We think is really important for both security teams as well as dev and DevOps teams as well.
Absolutely. So that concludes our first function for demo. So this is the less complex one. Basically, it's a super gullible function. We just saw it was executing anything that it got as input as command line. You may say that's not realistic. The next demo is where we're going to see something that's much more likely scenario in terms of a customer that's trying to use it for a real for an actual use case. Very, very common, also present in one of the samples. We're going to see how that could, for example, be manipulated as well. Before that, again, happy to pause for any questions at this point.
No, I
Okay.
think we're good.
Yeah, Raj, why don't we get to the second one, because this one really builds on the first one and kind of shows a more unique sort of case, but a case that we've certainly seen before. And this is particularly around execution through different invocations. So I'll let you set this one up.
Yep, sounds good. So let's start with this one, right? And I'm just gonna show a very high level architecture of how that one looks like. What we have in here is a function that is triggered by S3 bucket. So
it says your screen is still loading.
Still loading.
Yeah, it's still loading. Let's give it a minute.
Okay, let's
there
just
you
see
go.
from here.
That works. Yeah.
Yeah, I think if I do present, it's just anyway. This is okay. I'll just show it from here. We're not going to be in this slide for too long. So we have a Lambda function that is actually triggered from S3. Think of us as any file uploader. Like I have something called an awkward file uploader here. So I'm a photo sharing service. I have to log in to be able to upload an image and stuff like that. What I do is I want to know who uploaded this particular file, and I tag it with a meta tag within the image itself called exif. Usually used to store things like camera specific information. What was the shutter speed, ISO, what was the make of the camera, and basically parameters that the photo was shot with. So I'm using that to be able to upload and change the user ID of whoever uploaded this file, so I can use that to bring it back. So I have a Lambda function that triggers whenever a new image is put in this S3 bucket. All it's trying to do is to refer a database convert this user ID into username, hey, it says this was uploaded by user ID 1. For some reason, the Lambda is tasked with updating that information with the actual username of whoever is like uploaded the file. So that's all that the Lambda function does. It's reading a bunch of things from EXIF and rewriting that information by whatever it sees in the database. Similar to the DynamoDB example, but a more sophisticated one where you're just manipulating image EXIF data. So
and it's worth mentioning we see stuff like this, and the people that we talk to are absolutely worried about this, because this goes ahead and takes advantage of some of the weaknesses that we talked about in the serverless top 10. Maybe you have like a vulnerable supply chain, or you have a bad library or a bad dependency. And if you can sneak in something like maybe an OS command or a system command, could be, or like a SQL injection in this particular context, maybe through something like EXIF data, which seems benign on paper, but ultimately, like, it could lead to something bad downstream. That's ultimately what we wanted to show in this demo. So Raj, if you can maybe walk folks through like what's in the EXIF data, and then we can start to show like the before after, that'd be awesome.
That's right. So I have this sample image. This is a good image. This is how it's supposed to work out. We have the Imperva logo in here. I'm just gonna go over, and it's any whatever EXIF data that I could find on Google search and first result. So this is everything that it has. Like, it talks about the file type and stuff like that. What it's really using is the user comment field. So it's a dictionary, has a field called user ID, and it stores user ID as 1. So this is all that my initial image has. What the Lambda function is supposed to be doing is to be able to take this user ID and say that, hey, username is whoever is user ID 1 in the database. So let's go try this EXIF function out, right? Like for the EXIF data processor out. Again, not involving any protections, just trying to understand how the Lambda function itself works. So I have this bucket. I'm just going to upload, add a file. This could totally come through that UI. I'm just doing it here for sake of, just using it the way it is. Now we have this uploaded. My Lambda actually triggers whenever a new file is uploaded into S3, into that particular S3 bucket. So we do have this going on. So this was our latest event. Just a second.
There you go.
Yep. So we have the log in here as well. I want to go ahead and see, and what it does is it takes this and puts it in another S3 bucket. I'm gonna have to stop sharing, so I'm not listing every single S3 bucket that we have within this particular account. Just a second, I'll resume sharing.
This was Ulrich. This was Raj's second security test, and he's clearly passing here.
I'm too glad though.
Oh, I'm very excited, because otherwise we'd have to be getting off this thing and burning keys and accounts.
We don't know it.
Okay, there we are. So the EXIF test write is the bucket that my Lambda function is writing to. Let's get this one, right? User ID image underscore revised. I'm gonna download this, and let's go ahead and see what this image contains. Okay, yeah, so the image looks good. Let's go see what the user ID reads, right? So, okay, now it changed the user ID to something called user data. And it just says, user ID, username, which is in this case my name. User ID 1 was my name. So this is all we have. And this was actually what the Lambda function was supposed to do. So it did its job well and good. And the next time we retrieve the image, we know this was from this guy. I could use it in the UI. I could do a bunch of things around it without having to do it from a core logic. So again, the image is pretty good. Like, it was straightforward. The Lambda did the right transformation. This is what it was supposed to do, and it did that. Great. Now I have a malicious image, right? Like, let's just see how that works. I'm someone that's trying to manipulate this, take advantage of this situation. I opened a file. I knew what you were doing within the Lambda function. I just want to take advantage of it. So let's go ahead and see how this works. Okay, this is a malicious image, the source image, not yet processed. I'm just going to see what's happening in here, right? Classic run-of-the-mill SQLi command. Instead of saying user ID is 1, I'm just bypassing it with an OR command and saying, hey, 1 or user ID not equal to 1. So this is basically a tautology. This is always going to be true. As an attacker, I'm going to expect that this is going to return like a bunch of every single user ID and username that's out there in the database. Let's go find out what happens when I try to upload this image, right? This is the other bucket. Yeah, now I have 2 different windows for the buckets. So I'm going to upload my malicious image. Great. So that one worked. Let's go to our logs, right, to see what my Lambda did now that it saw a new image. There is a new log group. And remember, I do have protection enabled here in monitor mode so that the events have come through, which is great. Let's go find out what my exif test write has. It has an updated image with the revised suffix. Let's try downloading this. This was the processed image by the Lambda. Now I'm going to try and see, upload this processed image to see where things are. Okay, looks good. The image doesn't look any different. Let's go see where the user data is. Wow, okay. So it basically dumped every record in the database, and it gave me a list of all the users and their usernames, potentially exfiltrating data. So again, the image exif data is not a direct query string that can be parsed through any of the traditional kind of security mechanisms. This can only be understood with in-app context, because the payload itself is pretty benign. Like, it doesn't look like it has malicious intent at all. The image looked good. It was not corrupted. Nobody looks at scans exif data both at the perimeter level or even beyond to be able to see what's going on. It had they were just able to take advantage of a simple like they just realized, like, okay, well, based on the structure, it looks like it's querying the database this way, and I was able to ship out like all the 4 records that were there in the database. So let's try and see what happens when we turn on protect here, right? We did see what went on, and okay, let's actually go into the log itself. So this is the user data. I'm just printing this. We did log a high severity event. We said, hey, this is a database access violation. We do see that, this is what is happening. Like, there's a direct contradiction query, tautology query that's going on. And you get the same kind of visibility that you got previously as well. It talks about number of violations, which fields did it read. So there's a lot more context that you have once it's a database policy match. So you get a little bit into which were the fields that were read and stuff like that as well, along with the stack trace that we saw previously. In this case, this was using a standard psycho-PG library, which we hook onto, and it was able to really find out that this was what was going on. Other than that, you have a few the regular config-based events and everything else. But again, we filter on high severity. We really get to the point of where things are going. This was in monitor. The action was allowed. Let's go and turn this back into protect to see what's happening.
And Raj, while you do that, again, I think it's important to mention 2 things that you said that were pretty subtle, but I want to echo them. One is, for this particular example, you need context as to what's going on inside the function. In this particular case, like, how would you have stopped this using another security solution that wasn't in the function, right? Are you going to write something that is going to interrogate images as they're being uploaded and scan and open up EXIF data? No, you're not going to do that because people don't do that today. And then at the same time, like, you don't necessarily have a way to bring and basically add guards around all of these functional calls inside of serverless functions, because you may have lots of them. You may have lots of calls within each function that you need to effectively guard. And you don't know exactly what's going to execute outside, but you have full visibility as to what's happening inside, because you can see a database query before it executes. You can see an OS system command before it executes. And you have full visibility with like a language-oriented approach to understand what exactly is going to happen before it does. And that's the beauty of what we built, as Raj was saying, air-gapped, no code changes. And so, Raj, you just flip this thing back into a protect mode, right? Yep. So why don't we go ahead and show off what happens now?
Absolutely. So let's go to our source bucket and upload our malicious image. Again, I'm going to delete this. And that one is done. I'm going to upload our malicious image now. So this is the latest. Let's go figure out if this is gotten refreshed. Because our Lambda is supposed to be reading and writing to this particular EXIF test write bucket. We could also go check logs meanwhile. Okay, it seems like this has come. Yeah, the timestamp is latest. No, it is not, because the execution stopped. So in this case, you got a RASP exception saying query blocked. You get the entire trace back. And you also get the event itself that this was a database access violation.
So Raj, the recap is the attack payload was effectively someone putting in SQL injection inside of EXIF data and a bad image. And inside of the serverless function, we were able to detect the execution of a bad query that was going to execute maybe a query that contained, in this case, a tautology. So a statement of truth that would always execute. And we basically interpreted it, we saw it, we shut it down, and therefore the execution of the script itself just stopped, right? Because effectively we took a security action.
That is right, exactly.
Awesome.
That was actually very interesting overall. But I'm so glad you were able to walk us through for both of the demos. I found them to be really, really interesting. I'm not sure if you were almost done or are.
Yeah, I think that's it on like the high level demo side of things of what we wanted to show, and we effectively just only had one slide left that we wanted to share with everybody, which was, and Gitika, you've been sort of putting the link in as in the show itself, but let me go ahead and get my screen shared, because what we'd really love for people to do, if they're curious about this and they want to learn a little bit more, and I'm just going to get this shared one moment. If people really want to learn more and they want to try it out, this is available today. And again, part of the reason of why we're doing this is we believe that this is important. We believe that a lot of people probably want to better protect themselves. A lot of people want to better protect these Lambda functions. They may want better governance and security around Lambda functions. We think we built something pretty exciting. But what we'd love to do is get people's candid feedback and candid thoughts on this. Specifically, what we'd love to do is allow anybody to come in and try it out. So there's a web form you see below on the slide. You've seen the link being thrown up in Twitch repeatedly. We'd love for you all to go in and check it out. We believe this is something that's incredibly unique. This is going to provide a lot of value and just really help you get a sense as to A, what's going on, and B, stop bad activity from happening inside of your Lambda functions. We think that we built something cool. We'd love to get your feedback. We'd love to get your thoughts. Your partnership with us is something that we're all excited about. And, again, we'd love to get your feedback on this presentation, if you thought it went well, if you thought the topic was somewhat interesting. At the same time, if there are other things that you would like to see in a product or a demo or anything at all, just feel free to reach out to us using that particular link. Last but certainly not least, you can also reach out to either of us, Raj or myself. These are our email addresses. If some of you are curious about these demos, maybe you want to go a little bit deeper, you have some follow-up questions, we can do that as well. So our links to email us directly are here too. So Gitika and to Ulrich, thank you for having us and allowing us to share what we think is exciting about Lambda, great opportunity to build some new things, some of the security issues that we see in the space, specifically around Lambda. We walked through things like the OWASP serverless top 10. Raj walked you through two really cool demos, one more straightforward north-south demo, one more event-driven with things like S3. And hopefully we gave you all a good look as to what is going on in the space and hopefully why what we built is something that is going to A, resonate with you, and B, hopefully solve for these classes of problems that we are facing as an industry today.
Yep, definitely. I found the entire demo as well as product overview to be very interesting. I especially found the MySpace example to be interesting, and I know someone actually put that in the comment section as well. That I think some people will remember that definitely.
Shout out to Sean.
Ulrich, any takeaways? Anything?
Definitely. I mean, I think the first takeaway is I know both Kunal and I, we were using MySpace at the same time. So that must say something about our age. So the second thing, we also love Scooby-Doo. But at the end, I like to come back to, I don't know, Kunal, if you agree with me, there's a lot of those security issues. If we go back to the basic, that maybe can be overall avoided if people just follow best practices, right? By example, you mentioned one of the attacks would be like a privilege script, right? When someone just create a Lambda function and give that Lambda function admin role, right? And then that function can go anywhere in S3 and read, write, and do everything like they want. And I really like the aspect or Imperva is actually helping everyone making sure that those type of attacks that do not happen, and you're making sure that the cloud is secure, and the customer can actually making sure that their side of the security of the cloud is actually implemented. And thank you for that.
Ulrich, one thing that I think we'd be remiss if we didn't get to at the end here is we love the shared responsibility model. And I think for those people that don't know what that is, from a security perspective, AWS is going to secure its infrastructure, right? So if you are storing sensitive data in AWS environment, if you are building your applications, they're going to do the best in the industry in terms of protecting the infrastructure underneath all of those things. It is your job as an individual, as an organization, to secure your applications. It is your job to secure your data. AWS is giving you the tools. And that's why it's really important, as Ulrich mentioned, to do some of the basic things, right? At the very least, you need to apply some very basic hygiene, making sure that things are not over-provisioned, making sure that you're scoping things appropriately, that you built tight access controls and entitlements around what exactly is going on. So absolutely, I completely agree with you. I think organizations need to better grok that sort of shared responsibility model and understand that what we do isn't part of AWS. What we do is helping businesses better protect their applications, APIs, and data, while AWS is protecting the infrastructure that those things are running on top of.
Well said, Kunal.
Yep, exactly. Thank you so much, Kunal, and thank you so much, Raj, for coming in. And thank you, everyone who joined with us, and we'll see you next week.
Thanks, everybody.
Thanks for the opportunity.
Thanks, everyone.
Thanks, everyone.